All right, good morning. It's 11:11, make a wish. All right, you got it. You're welcome. So, 3 more lectures to go. You're almost done. You're this close to graduation. We got, for those of you graduating, there's always champagne and strawberries afterwards. Just think about that, right? There's a lot to do still. My head certainly feels like it's about to explode. There's so much going on. But all exciting things, right? The newspaper reserves all the bad news, and all the exciting stuff happens in international area studies on campus. So what we're going to do is we're going to keep on working on market failures, because I think that's a really fun way to look at the world, is to just simply figure out, if you leave people to make choices for themselves, and you leave firms to make choices for themselves, there are many settings where the resulting outcome is suboptimal from a social point of view. By the way, I keep on referring to Professor Karras. Then you guys tell Alan that I mentioned him in class, and he comes to me all proud. He's like, "You talked about me again today, didn't you?" I was like, "Yeah, I did." So this Malthus is a putz comment, that's stuck. All right, so that's now a thing. But back to where we were. So markets fail, right? Leaving people and firms alone sometimes leads them to make decisions that aren't optimal. We saw this very prominently in the case of a monopoly, right, where there was significant deadweight loss, high price, low quantity. We looked at monopolistic competition as well, where firms have a monopoly over a certain good, but there are close substitutes, unlike for a regular monopolist. We looked, interestingly, at the case for a natural monopoly, too, where a firm has increasing returns to scale everywhere, and what the optimal regulation there looks like to get us to something resembling the social optimum. Last time, we then went into and looked at price discrimination, right? All the firms prior, we always assumed that every customer charges the same price, pays the same price, right? So if I go into a store, I pay the same $4 for a pint of crappy beer that you pay, right? But that is not the case for all products. So some firms that have market power, meaning they can set price, and that's the important thing to remember here. A perfectly competitive firm can't price discriminate. Only a firm that can set price, and a firm that can set price by definition isn't a perfectly competitive firm. So a firm that can actually set price, somebody like a monopolist, what they could do is they could think about actually charging different individuals in this room different prices, right? So there are different ways of doing this. You could think of, for example, running an experiment where you ask everybody for the next unit consumed, right? What's your maximum willingness to pay that you would still buy this unit at? And then you say truthfully a number, which of course in reality you would never do. Lying is sometimes optimal, right, for you. Don't do it. It's bad, but still. So if you were to reveal the truth, the firm would charge you exactly that price. You'd hand over those dollars, and the firm captures the entire consumer surplus from you, because now the price you pay is exactly your marginal willingness to pay, which is reflected in your demand curve. So what we saw last time, this perfectly price discriminating firm, or a firm that first order price discriminates, charges everyone their willingness to pay for the next good, and the price for each consumer is what they're willing to pay, so it's captured by the demand curve. The mind-boggling outcome that came out of this was the fact that at equilibrium, right, in this market would produce where price, meaning demand, equals supply marginal cost, right? And we get to the socially welfare maximizing output level. So first order price discrimination is actually efficient, which seems crazy, right? And this again gets us back to this point. There's a big difference between what's efficient, meaning what maximizes social welfare, and what's equitable, what's fair, right? So the outcome is efficient. It maximizes the size of the pie, but the entire pie goes to the evil producer, right? Consumers get no more of the pie, no more of the surplus. So first order price discrimination is efficient, but certainly not equitable unless you put all the weights, the welfare weights, on the firm, because they certainly like it. They're going home with huge profits. Okay. So that was first order price discrimination. That doesn't really happen in the real world, unless you're so truthful, right? You're one of these really nice people who walks into the bar and you order your beer. The bartender says $4, and you say, "But I'm willing to pay $42 for it." And the bartender turns around and says, "Well, it's $42 then for you." It just doesn't happen, right? Perloff thinks he's come up with an example of perfect price discrimination, but I have to check that one, so I'm not passing that one on yet. Jeff Perloff, by the way, who wrote the textbook, is also a professor in the department I teach in here. So he's one of the most amazing senses of humor I've ever encountered. When he was department chair, he put a neon-colored carpet into the conference room, and for every department meeting, without noticing it, he always wore a sweater that matched the colors of that carpet. And nobody ever noticed that, except for 2 of us. So at some point, I was like, "This is amazing." He's like, "What? I have no idea what you're talking about." So if you ever run into Jeff Perloff, just a wonderful man. Okay, so that's first order or perfect price discrimination. Well, but there's a first order, there's got to be a second order, and sometimes a third order. So what's second order, or second degree price discrimination? So this is a scenario where firms actually don't know your willingness to pay, right? They don't know what your exact willingness to pay is for each good, but they're pretty sure that some class of consumers is willing to pay more, or some consumers are willing to pay more for some units than others, right? So for example, Max is probably willing to pay more for the first pint than you are, right? Why is that? Why does my demand curve look different from yours? I make a lot more money than you do at this point. Next year, that's going to change, right? But right now, I make a lot more money than you do, so my willingness to pay for the first unit and my desire to have a pint is probably bigger than yours, so my marginal willingness to pay is higher. So what these firms know is that there are some consumers that are willing to pay more for the first unit than others. So the aggregate demand curve is sloping down. So at really high prices, it's the Maxes, the Jeff Perloffs, the Josh Glances of the world. Well, Josh actually is way down. He's still a grad student. But maybe Josh's dad. I have no idea what Josh's dad does. Not either. All right, he's shaking his head. But people with really high willingness to pay come first, and then as the aggregate demand curve slows down, slowly the graduate students and then the undergraduate students filter in there too. So what this firm does here is it varies the price that different consumers pay, right? But what it doesn't do, which is what we're going to visit next, is do this sort of student discount versus non-student discount thing here. What we're thinking about here is that there's simply the price each customer pays varies with the number of units a customer buys, right? So I buy these cruddy shirts, so I resemble like a serious person, and the company I buy the shirts from has these sales, right? I haven't bought a full-price piece of clothing in a decade, right? You can tell. But the point here is, what they have is they have these sales where, you buy one, you get one free. Sometimes if it's really good, you buy one, you get 2 free. So this is the extreme version where the price of the first unit is different from the price of the second unit. What you see more frequently, and if you're less cheap than I am, you see sales all the time, buy one, get the second one 50% off. I mean, who here has not seen buy one, get the second one half off? Anybody? If you haven't been in a store, right? We do this all the time where the price of the second unit or the third unit or the price of the first 5 versus the second 5 is different. So the notion here is that the price only varies with quantity, right? There's no student versus non-student price here. There's just how much are you buying, and that varies the price that you pay for each unit. So for a given quantity, everybody pays the same price. you just also want to make sure that not all quantity discounts are a form of price discrimination, but the ones you encounter at the mall certainly are. All right? So generally speaking, if you see different prices for different quantities, sometimes there's average costs that are dropping and prices drop the more you buy. That's not necessarily price discrimination, but in this case, the examples I've given you certainly are. Okay, so what does quantity discrimination look like? So let's look at it. Okay, my printer wasn't working, so I have my drawings on my computer. I'm working with two screens today. I apologize. Not that you care. All right. So dollars, quantity. What I want to do is I want to assume that there's a flat marginal cost of $30. It just makes things simpler. All right, so I'm going to draw a constant marginal cost curve, so producing one more unit always costs $30. So a flat marginal cost curve looks something like this. So this is the price discriminator. And then I'm going to make this price discriminator face a demand curve. The demand curve is nice and blue. I'm going to make this go through 9, 9 here. That's the demand curve, intersects at 90 units here, 90 units here. And what I'm going to say here is that what this particular firm is going to do, they're going to charge, $70 for the first 20 units, and then $50 for anything above that. Okay? So $70 for the first 20 units. So just draw a dashed line down here. And then $50 for anything thereafter. So my price schedule here is 70 for the first couple of units, and then 50 thereafter. Set these equal. Equilibrium quantity is going to be 40. Right? If they just charged $70 per unit, this demand curve here would simply buy 20 units. But what they're doing is once you've bought your first 20 units, we'll sell you some more. Right? We'll sell you some more at $50, but you have to have bought the first 20 first. So if they would have just said 70 is everything, they would have sold 20 units. This way what they're doing is they're selling 20 units at 70, but they're capturing this additional portion of demand here by offering a lower price for additional quantities once the first 20 have been bought. Right? So without price discrimination, the firm sells 20 units at $70. With price discrimination, the firm sells 40 units, 20 of which they get $70 for, and another 20 of which they get $50 for. So what does welfare look like here? So we've done so many of these consumer and producer surplus graphs that I'm getting faster with these. If this is freaking you out, come to office hours, mine or the GSI's. We're happy to help you. But by now, what you should figure out is, right, the socially optimal quantity and price here, this here would be the social optimum. Right? At that quantity and price, what we would have is consumer surplus, area between demand and price, $30 over the range of consumption here. So this whole big triangle from 90 to 30 out to Q double star would be consumer surplus, and there is no producer surplus. That would be the socially optimal outcome. Now what happens under price discrimination? Well, under price discrimination here, in this quantity setting, consumer surplus is, as always, the area between demand and price over the range of consumption. How much do consumers consume? They consume 40, right? What's the distance between price and demand? Well, for the first 20 units, it's the distance between 70 and the demand curve. So it's this thing right here. For the second 20 units, it's the distance between price, which is now 50, and demand over this range of consumption. So Max, I know what you're going to do now. You're going to put numbers on this, aren't you? Yes, I will, all right? So what I've got here is I've got a triangle that's 20 units tall, 20 units wide, right? I know the area of this thing here is going to be $200. Same thing here. I've got a triangle that's 20 units tall, 20 units wide, 400 divided by 2, that's $200. What about producer surplus? It's the difference between marginal cost and price over the range of production. So for the first 20 units, bless you, for the first 20 units, it's the distance between price, right, $70, marginal cost of production. So it's going to be this area right here. For the second 20 units, it's going to be the area between the price they get for these units and the marginal cost of production. So it's this whole nice Tetris piece. This is my favorite Tetris piece right there. It's undervalued, but it's a good one. So this one right here, you can figure out what producer surplus is, right? Producer surplus is 20 times 20, 20, 20. 20 is 400 plus 400 plus 400 is 1,200. So this rectangle here, or square, is 400. This is 400. This is 400. Now, what I've got here is, now I've got $400 of consumer surplus. I've got $1,200 of producer surplus. Is there any deadweight loss? I like that answer a lot. Who said that? You're right now my favorite student, because that was an enthusiastic, correct answer, the best kind. All right, so what we've got here is, right, we know that at the social optimum, we're producing Q double star right here. We're charging a price of $30, and this is demand. So total welfare is going to be this huge triangle right here, area under demand, out to amount consumed, over price. So it's going to be red, red, yellow, 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 plus this thing right here. Right? Q double star is not going to be a surprise of 60. If you figure out the math, you would see that. So what I've got here, I've got another $200 of deadweight loss. Right? So welfare at Q double star, which is the social optimum, would have been 200 plus 200 plus 200, we're at 600, plus 400 is 1,000, plus 800 is 1,800. Welfare at Q star, that's supposed to be an at Q star, which is not the social optimum, is going to be 1,800 minus 200, it's 1,600. That gets me deadweight loss of $200. Who loses big time? Consumers, right? Consumers before had $1,800, 1,800 of consumer surplus. Now they have $400 of consumer surplus. So they lost $1,400 worth of consumer surplus. Producers previously had zero producer surplus. Now they have $1,200 of producer surplus. So out of those $1,400 of consumer surplus that has now gone away from consumers, $1,200 are recovered by producers, and $200 go to deadweight loss. Right? So this quantity discrimination right here allows producers to sell these additional 20 units here and rake in some more money right here, and it also takes away consumer surplus from consumers. Okay, Max, Here's what I want you to be thinking. So I'm going to pretend to be the voice in your head for a second, and I hope you're slowly starting to hear these economic voices. They're really useful when you're in econ classes. But the point here is, that's interesting, Max, but if this is truly a price discriminating monopolist, getting excited, that price discriminating monopolist here isn't going to produce Q double star. He's a monopolist, right? He will produce the monopoly solution. So really, why are we comparing the socially optimal outcome to that of price discrimination when the monopolist left alone will produce the monopoly outcome? So let's look at what the monopolist would do if he were left alone in this setting. Well, I'm glad you asked. So let's look at the monopoly solution. I'm going to do that a little bit quicker, okay? So marginal cost for this monopolist, also $30. Demand is the same as in the other picture, bless you. So that here's demand. But now where does that monopolist produce? Well, Max, I know, it's where marginal cost equals marginal revenue, so I need to draw the marginal revenue curve, correct. So this marginal revenue curve intersects right here at 45. Marginal cost equals marginal revenue at 30 units. The monopolist charges $60. And what do we get? We get consumer surplus. So this is now going to be a triangle that's 30 units high, 30 units wide, so $450. Producer surplus is going to be a rectangle that is 30 units high, 30 units wide, so this is $900. And deadweight loss, since this here still is 60, is 30 times 30 over 2. Right? So welfare at QM, which is 30, is what? Welfare is 900 plus 450 is 1350. Deadweight loss at QM is what? 450. Consumer surplus at QM is 450. So let's compare these two outcomes, right? This is what the monopolist would do, left alone. This here is the price discriminating firm and the perfectly competitive firm. So what I want us to compare is the monopolist left alone, which is one evil version of the world, and the other one is the price discriminating monopolist. Who does better, who does worse in this particular setting with this particular demand curve and flat marginal cost curve? So let's look at consumers. Consumers under price discrimination, $400 worth of consumer surplus. They actually do better under the monopoly. They get $450 worth of consumer surplus. How about producers? Producers under price discrimination get $400, $800, $1,200 dollars worth of producer surplus, and here they only get $900. So they actually do better under price discrimination right here. From a societal point of view, given this particular demand curve and marginal cost curve, deadweight loss for the price discriminating monopolist is $200 versus the monopolist left alone, it's $450. So here again, we get the same sort of strange intuition where having a monopolist who's allowed to price discriminate is actually better for society in this particular setting than letting the monopoly just be a regular monopoly. So why would not every monopolist price discriminate according to quantity? Well, A, it depends on what your particular market looks like, right? What does your marginal cost curve look like? What does your demand curve look like? And remember, in order to successfully price discriminate, you've got to be able to do a couple of things, right? Transactions costs have to be low. You've got to be able to prevent resales, right? So these are things that don't work out for every particular monopolist right here. So they do certainly try and prevent resales, but it's not always possible. So that's quantity price discrimination. But next, how about that Fast and Furious example that you gave us last time? Well, how about multi-market price discrimination, right? And this works in a variety of settings. So all you need to be able to do is you need to be able to segment consumers into multiple markets, right? And a market isn't necessarily a spatial thing. It could be a category of consumers. So if we're thinking about people shop on the internet and they buy stuff. So the internet isn't necessarily spatially differentiated, right? It's a thing that exists somewhere. I don't understand how it works. But the point here is you could think of markets as classes of consumers that are differentiated based on some characteristic. You're a student or you're not a student. You're a senior, you're not a senior. You live in London, you live in San Francisco, right? But there are groups of consumers that share a characteristic based on spatial location or some other observable characteristic, membership in some organization, right? If you've got a AAA card, you can get a $2 discount on a hotel room that costs $600. It's pretty amazing. So I'm joking, they do better than that, but it's at least $8. But the point here is this multi-market price discrimination stuff happens all the time. So what is it? Firms spend a lot of money trying to figure out what we call customer segments, right? Who here has never heard the word customer segments? Really? All right, excellent. I taught you something new for once. So customer segments just basically means you look at all the potential customers and you split them into groups, right? Into groups that have things in common, right? The gamers, people who play video games instead of going to the theater, right? What are you doing? Looking at people based on their age, looking at people based on their preferences. So firms spend a lot of money trying to segment customers to essentially do exactly this. Can you somehow set a different price for these groups and all the while preventing resales? So let's think about how this works. Whoops, what just happened? There we go. So think about the following example. Think about a spatial